fall into something and it's fun, you tend to stay with it.
Hearing the memories that people had about the structure. You know, it's almost like a good Irish wake when you take down a building.
Stacy started working with us when she was just a wee little girl. At the age of 3, she was out pushing buttons on bridges and posing for photographers.
I've seen my father go into buildings and, laugh and shake his head and say, I can't, you took one column out here and this building would not stand. I've never been frightened of explosives. I've always had tremendous respect for them. Talking about an unbelievable amount of power that can be harnessed and used effectively.
Explosions create gas, and that gas expands at a certain speed. And as that gas expands, anything in its way is going to be broken. Basically, rapid expansion of gas that moves literally mountains.
When this particular mountain exploded over 100 years ago, it was the largest blast ever recorded. The volcanic eruption of Krakatoa was heard 3,000 miles away. Shockwaves from the blast started a tidal wave that killed 36,000 people. The force of Krakatoa, 500,000 times larger than the bomb at Hiroshima, is the benchmark for all natural or man-made blasts.
Nature is the ultimate source of energy. Explosives is pale compared to a seismic event, megatons of energy released across a huge expanse of the landscape. Man can't hope to touch that, but explosives is about as close as we can come.
The 32 stories of the Mendes Caldera building make it the tallest building ever demolished with explosives. It took a mere 1,000 pounds, detonated on 10 key floors. When this building was imploded into its own basement, it put the Loiseau family into the record books. Implosion, the key to their success, is the science behind controlled demolition. Small amounts of explosives strategically placed and detonated in sequence.
The real damage that is done to the building comes from gravity, pulling the structure down. The explosives are more catalytic in terms of building demolition. It just gets the reaction going. Once the building starts moving, it's very hard to make it stop.
Today, in the Loiseau's hometown of Baltimore, a multi-story housing project awaits destruction. The challenge? Turn 5 buildings into rubble and leave the surroundings untouched.
The first thing we do on a site review is choose a direction of fall. And that decision is almost always based on the adjacent exposures or the adjacent properties. What's around the building that we can hurt? And you can see these buildings are all sitting on major streets. And so in this particular instance, we're going to bring the buildings away from whatever street they're sitting on.
The streets around the site are just part of the problem. The 5 buildings are surrounded by a raised freeway. Baltimore's main hospital with its dust-sensitive air intakes, community housing, a church, and bang in the middle of the site, the playground and classrooms of a preschool. To create the minimum of disturbance, the Loiseaus will control from the start when and which way each building is going to fall.
If you want a structure to fall this way, of course you take out more on this side than you do on this side. And that's basically what we're doing. The way this is prepared, this corner wall, this corner of the building is going to fail this way. So we don't want it to eliminate the columns on upper floors on that side because it'll tend to either come straight down or it will fail in that direction.
To calculate the amount of explosives he needs to eliminate each key column, Doug carries out a series of test blasts.
Here's a good example of a test blast, right here. You can see how the covering material is bowed out. The concrete is totally destroyed. But we've cut this fabric back. When we did the test blast, everything was contained within the column itself. But once we cut it off, you can look, that has no structural capability left.
The test results give a kind of X-ray of the concrete columns, exposing the steel reinforcing bars that hold the structure together.
On this particular project, Doug in the field has found out that a lot of the reinforcing in the column varies quite a bit. So the loads that we intended to use, are changing now. Some of them were increasing, some of them were decreasing, depending on the actual reinforcing column to column.
Doug will load each hole with explosive, using only enough to blast away the concrete and cause the column to fail.
Explosives detonates to the area of least resistance. A gun, when you set a gun off, least resistance is out the barrel. If I have a wall or a column that's drilled off center, the least resistance is out to the one side. So I'll have more fly in that direction. So by looking at each hole as I'm loading and looking at the steel that they've hit in the hole can tell me exactly what the loading density will do. Or I may skip some of these holes.
There are over 1,000 different types of explosive, different because they detonate at varying speeds. Powder, liquid, or gelatin. Nowadays, they all have one thing in common. They're relatively safe. But it didn't used to be like that. Blasting was a pretty hit-or-miss affair. It wasn't until a Swedish chemical engineer saw his brother accidentally blow up the family's nitroglycerin factory that explosives were to become anywhere near as safe as they are today. In 1867, Alfred Nobel gave the world safety blasting powder. It was, in fact, a highly explosive putty made from the chemical nitroglycerin and sandy earth. Mixed by hand in rubber-lined wooden boxes to avoid sparks, if treated with respect, it was safe to manufacture and transport. Nobel changed the name to dynamite, set up factories all over the world, and in many ways changed the face of America.
Rapidly taking shape